Hello, Python coders. In Chapter 3, we're going to look at programs that can make decisions. One of the main reasons that we value computers is that they can make decisions for us and at very high speed, as you know. Well, in order to write programs that make decisions, we have to get used to working with the relational operators. Now, I think you already know some of these. They're on page 122 in our textbook. They're greater than, less than, greater than or equal to, less than or equal to, and then not equal to. So there's a number of different ones. Now, right here, as you can see, I've got the interactive window open, and I can test expressions or lines of code in this window. So I'm going to assign 10 to a variable num, as you can see here. Now I want to try writing a Boolean expression using that variable. So I'm going to go with num is greater than 5. That's true. You can see I've used the relational operator and the literal value 5. If I were to modify that a little bit, num is greater than 12. Well, that's not true. That's false. Okay. We could, though, say num is less than 12, and that would be true. Now, I could also try the equals operator. Double equal sign. Notice the difference between the single equal sign up here. That's an assignment. That's where we're assigning a value to the variable num. A double equal sign means we're testing to see if the num variable holds the value 10. So this is a test for equality. So be careful when you're writing a test like that. I could do other things. I could say num equals 12 minus 2. That's also correct, of course. So you can have expressions over here. If they evaluate to the same value as num, you will get a true when you use the double equal sign. Let's go with the not equal to. Num is not equal to, that's an exclamation mark equal sign. Num is not equal to 8. Well, that's true. It's not. It's 10. It's not equal to 8. But is num not equal to 10? No, that's false. Num is equal to 10. So num not equal to 10 comes out as false. Okay, so those are your relational operators, and you can use those to make Boolean expressions. And typically, you do that in a program by using the if keyword. Okay, you use the if keyword. So, for example, you might have something like if num equals 10, and we know it does in our case. And then you finish your if expression with a colon. When you press enter, you'll see that your next line is indented by a tab, and that's important. So I'm going to put here, I'll just say yes. Num is 10. Now I have to press enter twice in this interactive mode for that to execute, but as you can see, it does work properly. So that's your basic functional decision-making statement in Python, or any language actually. You use an if statement. Okay, now there's a few other things that we need to know. I'm going to fire up one more interactive window. And just try a couple of things with those string variables, because I was working with numbers here, obviously, but we can also use string variables here too. I'll go with name equals Guido. Guido van Rossum, of course, is the man who developed Python. He's the originator. They call him the BDFL, the Benevolent Dictator for Life. Now, let's see. Let's do a test. Name equals Guido. Test for equality. Yes, it's true. Name does equal Guido. Now here's an interesting one. I'm going to try and is greater than Anna. Okay, greater than. Well, what does that mean in the relation to strings? What is greater than equal, greater than mean when we're talking about strings? Well, this turns out to be true. They compare exactly the same except for the last letter, right? The last letter is different in each string. Well, as it happens, the ASCII code value for E is 101, and the ASCII code value for a lowercase a is 97. So 101 is more than 97, so Anne is more than Anna. Now, you might say, well, where am I going to use that? Well, Python will use that to do sorting. When you're sorting in Python, you might think you're sorting by the characters, the letters of the alphabet, but really you're sorting by their ASCII code values, the numeric values. Likewise, that's what you were doing in Microsoft Excel too. You probably sorted a column in Microsoft Excel. Well, you were really sorting it out numerically, not alphabetically. Okay, we just wanted you to see that. Now, just got one little program that we want to show you, and this is a very important concept. We call this one odd even, as you can see. What we want to do is report an integer as odd or even, and computers, believe it or not, a lot of people don't believe this, but the computer does not know that 3 is odd and 4 is even. Computer only knows zeros and ones, bits. A computer program, however, can make the decision, the determination. So here we have a program. We're going to ask the user to enter an integer. And here's the secret. Here's the secret. I guess you could call it a secret. The remainder of an odd number when divided by 2 is equal to 1. So if you divide a number by 2 and the remainder is 1, you got an odd number. If you've got a remainder of 0, you've got an even number. So we wrote this one to do a test. If num %2 equals 1, if the remainder when we divide by 2 is equal to 1, well, then we'll report that this is an odd number. And of course, if it's not odd, it has to be even. So that's where the else block kicks in. Very often in a program, you'll want to do something if a condition is true. So if this condition is true, we'll run this line of code. But sometimes you also want to run a different branch of code. In this case, we only have one statement in each branch. And that's where the else block would kick in. Okay, so just wanted you to see that as a first program that uses if and else to make decisions. And you want to remember this rule about odd and even numbers. Okay? All right.